Hello.
Yes, sir.
Yes, sir.
Fine.
Connect.
So I think, see, offline class there was a lot of noise were there. At least online class there should not be any noise. This is the third module, where third module basically deals with the two topics. One is feedback amplifier, another one is the power amplifier. Feedback amplifier, as yesterday's class, we were just feeding back the signal to the input of the MOSFET. Now, an amplifier, we are going to get some output, and that output is going to be fed back to the amplifier for further amplification. So that is the topic what we are going to have in feedback amplifier, and in that one we discuss these topics which is mentioned: general feedback structure, properties of the negative feedback, the four basic feedback topologies: series shunt, series, shunt, and shunt series amplifiers. Means four different topologies what I am saying. Okay, these are all qualitative analysis we are going to discuss. One is, if it is series to shunt topology, what exactly it's going to happen, how exactly an amplification, a feedback and amplification is going to happen. Similarly, series to series, similarly shunt to shunt and shunt to series. Four different combinations we are going to have. These four different combinations we are going to discuss in feedback amplifiers. And next part is power amplifiers, that I am going to discuss later stage. Let us concentrate only on feedback amplifiers as of now. After the IA, we will be discussing about the power amplifiers. So moving ahead, let us go for, I'll share one more screen. I need to stop sharing. I should go for sharing the screen of other one, the topic. Yeah. I think the screen has been shared once again, the different screen. I need acknowledgement from your end. General feedback structure. Are you getting general feedback structure screen? Are you able to see? Hello? Hope I'm audible. Kindly acknowledge from your end. Yeah, good. Syed, thank you. Syed. So there was some network issue. That's why I could not continue. Let me continue my session. The diagram, what it is showing is the feedback structure, general feedback structure. Any circuit you are having over there, any component you are having, or you consider a block which is having a gain, that is A, which is from the input to the output is coming. Later, whatever the output we are getting, is X naught. Okay, it may be a current signal, it may be a voltage signal. This is the signal. Just a second. Say. Sorry. Okay. See, the people here is a little bit they would have at the top, they would have amplifier, they put the amplifier, and we're able to put the gain. Once you get A, again, the output X naught. It may be a voltage signal, it may be a current signal, and that output signal we are feeding back once again to the input of your amplifier. Feeding back. See, this input feedback signal we are going to have. Both we are going to add, and finally we are going to have Xi as the next input signal to the amplifier, and that will be amplified, and finally we are able to measure the signal. X naught is the output, which is equal to amplification factor, that is a gain into the input signal. Okay, the basic amplifier is unilateral. It is clearly saying that the basic amplifier is unilateral and has a gain A, which is known as the open loop gain. Thus, its output X naught is related to the input Xi by 1. So I repeat once again, till now we have discussed only amplifier separately, and we have discussed the there is oscillators. In oscillators, we are having feedback. In amplifiers, we are not having the feedback. But here we have an amplifier with the feedback signal. So let us see how exactly it's going to work. The feedback network measures or samples the output signal X naught and provides a feedback signal XF. So it's going to measure X naught, and that XF will be fed back once again to, that is related to X naught by the feedback factor B naught. A is the amplification, that is gain, and beta, what we are going to have is the feedback factor. So Basically, we assume that xf is same as x naught. That is what is the output we are getting, the same thing we are feeding back to the input, but that is not the case. We have a feedback factor called beta. It is assumed that connecting the feedback network to the amplifier output does not change the gain. We assume that one, but basically it is going to change. The feedback signal xf is subtracted from the source signal xs. Why? Why it is getting subtracted? In the yesterday's class only I told that one amplifier generally it will be in the 180-degree phase shift. It's going to provide the 180-degree phase shift. That means it will be having a negative signal over there. That is going to get subtracted. That is xf is subtracted from the xs, so that you are going to get the xi as the input signal, the second input signal of your amplifier. Initially it is xs because we are not having any feedback initially. But once one output has been generated, that is been fed back, so it will be subtracted, and after subtraction, you're going to get a xi as the input. Here we note that it is this subtraction that makes the feedback negative. In essence, negative feedback reduces the signal that appears at the input of the basic amplifier. Here too, we assume that connecting the output of the feedback network to the amplifier input through the subtractor or differentiating circuit does not change the gain A. This is the feedback network does not load the amplifier input. So the closed loop, generally we have the gain is, we are going to measure x naught by xi, x. You want to get the expression for AF, that is AF is equal to A divided by 1 plus A beta. The quantity A beta is called the loop gain. In the previous class also, when we are explaining about the oscillators or amplifiers, there also we have come across the loop gain. The feedback is negative, it's a loop. Okay, the loop gain AB must be positive. That is, the feedback signal xf should have the same signal as S, so that you will not get positive or negative. If as the case in many circuits, the loop gain A beta is large, more than 1, then AF is 1 by beta. AF is 1 by beta, which is very interesting result. So let us see how exactly it's going to work. XF is A beta and divided by 1 plus A beta into overlap, the input signal also. A beta is greater than 1. We see that XF is almost equal to XS, which implies that the signal Xi at the input of the basic amplifier is reduced almost to 0. Thus, if a large amount of negative feedback is employed, the feedback signal XF becomes almost so if feedback is amount of negative feedback comes, then XF is almost equal to 0 into difference between XS and XF, which is accordingly the input difference circuit is equal to 1 divided by AB. It's very simple. See here, simply in general, how it looks into and not the output, but we are not stopping at the X naught itself. Are being they, but when we do extent, consider the input. You should know gain. You should know what is A. You should know what is A beta, and you should know what is X. These are all the parameters you should know whenever you go amplifiers or whenever you go for the feedback amplifiers. Any clarification here? Any clarification? So I can move on to the next topic. Any clarification? Let me check it out. Screen not display. Hello? Kindly text for any issues. Everyone, am I audible? Hello, am I audible?
Yes, sir.
So now I think let me share through mobile itself because getting connecting to system it's taking time. Just 1 minute, I'll just share my screen. Screen visible? Hello? Yeah. Hope you are able to see my screen. Hello? I need some acknowledgement from your end. Otherwise, it will be difficult for me to continue. Kindly acknowledge. Okay, sir. I am also new to this. Backside ಇರ್ಬೇಕು ನೋಡಿ. Hello? Dear students, kindly acknowledge. I need some support from your end. If you are not able to acknowledge me, then it's very difficult for me to continue. Lot of network issues are there here. So the statements here, it says loop gain is very important. That is A beta. In fact, the most important characteristic parameter of the feedback amplifier is always a gain or loop gain, because we are going back, we are feeding back. Previously, we are checking only the gain where there was no feedback. But now we are having the feedback, we call loop gain. A signal sign of A beta, that is loop gain, determines the polarity of the feedback. The loop gain A beta must be positive for the feedback to be negative. If the feedback is negative, then the loop gain should be positive. The magnitude of AB determines how close the closed loop gain AF is to the identical value of 1 by beta. So it is just a relation, gain and beta, that is feedback factor, both will be there. So you should know, you should correlate them itself. The magnitude, see, these are all the characteristics what we are going to measure, what we are going to identify when we are discussing about the feedback amplifier itself. So there is a question on what are the characteristics of the feedback amplifier. What are the major important parameters we need to measure when we are going for the feedback amplifier. It is inevitable variation of A beta with frequency can cause A beta to become negative. So with respect to frequency, it may become negative also. So this is what has been given. Determination. Determining the loop gain by breaking the feedback. See, we are breaking the feedback here in this circuit. XR and XT, we are going to have, previously we are calling it as XF, that is XF is the feedback. And since we are breaking the circuit, breaking the feedback, we may get different value itself. Determining the loop gain by breaking the feedback loop at the output of the basic amplifier, applying the test signal XI and measuring the returning signal XR. That is returning signal, we'll call that one. XT is what we are going to apply, and returning signal is XR, which is equal to A beta is equal to minus XR divided by XT. Oh, it's there, ma'am. So presentation, I have just given is the gain of the feedback amplifier, what is the loop gain of the feedback amplifier, and what are the characteristics. The main characteristics of the feedback amplifier is the loop gain itself. So you need to read these topics as of now. I will be continuing in the last hour. I'll come and I'll see in detail what exactly loop gain and all. So meet you at 3 o'clock in the offline session in the classroom. I'll be coming by 2:30. I'll be taking the class in the classroom by 3 o'clock or the last hour, 7th hour. Don't miss that one because it's very important. You should know and it will be useful for you also. If you miss the class, then it will be difficult. Okay, don't miss the class. My sincere suggestion is don't miss the class so that you will get the more concept about what is loop gain, how exactly we can measure, how to, if I break the feedback, what is the effect of that one, what is the negative feedback effect. I mean, if I want to get the positive gain, what I should do, everything will be discussed in the next class itself. And stopping my session now. Okay, so these are all some of the I'll because I'm not share screen. I am not in a position to see. That. I'll be coming afternoon session. Thank you.